Hey there, Learn here. In this video, we're diving into the world of programming, what it is, how it works, key terms, and more. Grab your coffee, a drink, or whatever you enjoy, and let's explore this exciting topic together. What is programming? Programming is simply the act of telling a computer what to do using a language it understands. It's how apps, websites, games, and all kinds of digital tools are created. Just like humans speak different languages, computers understand different programming languages. To communicate with a computer, you need to learn one of these. While this video won't teach you a specific programming language, it will introduce you to the basic terms and concepts you need to get started. Data types tell the computer what kind of data it's dealing with, and what actions can be performed on it. For example, if the data is a number, you can perform basic math operations like addition, subtraction, multiplication, and division. But if the data is text, like a name, the main operation you can do is addition, which in this case means concatenation, joining texts together. Different programming languages may use different names, but here are some basic data types you'll commonly find. String, for text, like names, sentences, or gender. Integer, for whole numbers. Float or double, for numbers with decimal points. Boolean, for true or false values. Lists or arrays, for collections of data. These data types form the foundation for how computers understand and work with informations. To work with data, you need a place to store it, and that's where variables come in. Think of variables as containers that hold data, and as the programmer, you get to name these containers. In some programming languages, you can store any type of data in a variable, and even change the type later, for example, storing a number first and then replacing it with text. These are called dynamically typed languages. On the other hand, in statically typed languages, once you assign a type to a variable, like an integer, you can't store a different type, like a string in it, without causing an error. In the illustration below, you'll notice that each variable has a unique name. This is important because if two variables share the same name, one might accidentally overwrite the other, leading to bugs in your code. A typical variable follows this structure. Variable name equals value. This basic format helps you store and manage data effectively throughout your program. Programming languages provide a variety of operators, which are symbols or keywords used to perform specific operations on data. These operators are grouped into different categories based on their function. Arithmetic operators, used for basic math operations like addition, subtraction, multiplication, division, and modulo, which gives the remainder of a division. Logical operators, used to compare Boolean values. The most common ones are AND, OR, NOT, comparison, or relational. Operators, used to compare values in conditions, such as greater than, less than, equal to, not equal to, greater than or equal to, less than or equal to. Bitwise operators, used to perform operations at the bit level, often for low-level programming or performance optimization. Assignment operators, used to assign values to variables, such as equals. There are also shorthand versions. Increment and decrement operators, used to increase or decrease a value by 1. Understanding these operators is essential, as they form the building blocks of logic and computation in any programming language. Conditionals are parts of code that let your program make decisions. They control what should happen depending on whether something is true or false. Most programming languages offer different ways to handle conditions, including if and else, the most common way to run code based on a condition, switch, or match in some modern languages, used when you have multiple possible values to check against. It's often cleaner than writing many if-else blocks. Ternary operator, a short way to write simple if-else conditions in one line. These conditional structures help your code make logical choices and respond to different situations during execution. A condition is simply a statement that can be either true or false. For example, 4 less than 5, this is true. Age greater than 18. This checks if the value of age is greater than 18. Loops allow you to repeat a block of code multiple times, either a set number of times, or until a certain condition is met. This helps you avoid writing the same code over and over again. There are a few common types of loops. For, used when you know ahead of time how many times you want to run something. While, runs as long as a certain condition is true. Do. While, in some languages, similar to while, but it runs the block at least once before checking the condition. Loops often go hand in hand with variables and conditions. You can use them to process lists, repeat actions, or perform tasks until a specific result is achieved. Just remember, always make sure your loop has a way to stop. Otherwise, you might create an infinite loop that never ends. Bugs are errors or mistakes in your code that cause it to behave unexpectedly or not work at all. They can be as simple as a typo, or as complex as a logical error that's hard to spot. Common types of bugs include syntax errors, breaking the rules of the programming language, like missing a colon or bracket. Logic errors, the code runs, but the result isn't what you expected. Runtime errors, errors that happen while the program is running, like dividing by 0, or using a variable that wasn't defined. Debugging is the process of finding and fixing these bugs. It's a key part of programming. Even experienced developers spend a lot of time debugging. Ways to debug include reading error messages. Most programming languages give helpful clues, using print statements to check the values of variables at different points. Using a debugger tool, available in most code editors, these let you pause and inspect your program step by step. Thinking through your logic. Sometimes the fix is in the idea, not the code. Debugging isn't a failure, it's how you learn and improve. Every bug fixed is a step closer to becoming a better programmer. We post shorts daily, bite-sized snippets designed to help you learn on the go. Subscribe now and join the waitlist for the Learn platform, where learning meets simplicity. Subscribe, follow, and like for more snippets.